SYN Flood attacks can be launched at a massive scale. Typically, for distributed denial-of-service attack, a large botnet can be used to generate a huge amount of traffic. And the result is that the website or even its uplink network routers can be saturated. It is very hard to filter these SYN packets because they all look legitimate. So how do we defend against such massive flooding attack? One idea is to use a very powerful server or a group of servers to protect a website. The idea is that these intermediate servers will only forward established TCP connections to the real website. Suppose many machines or bots send a lot of requests to the website, but they're intercepted by the proxy. The proxy is very powerful because it can use many servers, and they can be distributed across the internet. The proxy sends the SYN ACK packets in response to the initial SYN packets. When the proxy receives the ACK packets from the client, it will then forward to the real website. The idea here is that the attacking machine or the bots will not send actual ACK packets to the proxy. Only the legitimate client will send the ACK packets to the proxy, and only those will be forwarded to the website to be serviced. In other words, the proxy here stops the flooding attack. However, the idea of using proxy to protect a website is not bulletproof. Here's an example of a stronger attack. An attacker can use an army of bots to actually completely finish the TCP handshake. In other words, it uses complete TCP connections to a website. It can send requests to the website and keep repeating all these requests to the server. That is, all of these requests are legitimate from the protocol point of view, but they were designed to overload the server with a lot of work. And the result is that if the attacker can command a huge army of bots, the attacker can still bring down a website. This is similar to the situation when there are a huge number of legitimate users visiting a website at the same time. Of course, such attack can actually render the proxy protection useless. But on the other hand, because the TCP connection is fully established, that means the attacker cannot use any random source IP address. The attacker must use the real IP address of the bots, which means that the bots' IP addresses are now revealed. And then the proxy can actually block or rate limit traffic from these bots. In other words, after the initial attack, there's a chance that the proxy can actually use the information to rate limit and then reduce the effect of the flooding attack. Here's a real-world example of such an attack. It's fairly recent. So here, an honest end user visits a popular website. But this website is compromised, and the response will include a malicious JavaScript injected into the response. And the user has no idea that this JavaScript is embedded into the response HTML page. For example, this JavaScript can be embedded in an invisible iframe. Once the response HTML page runs on the user's browser, the malicious JavaScript will run, and it will do a denial-of-service attack on a server, say github.com. Here's how the JavaScript can launch attack on github.com. It basically asks the victim website, say github.com, to fetch a random resource on a server, and it sends such requests every 10 milliseconds. Therefore, with many users unknowingly running this malicious JavaScript, the victim website, say github.com, can be rendered unavailable.